All right. The last type of question you will see is something like this. So one of the questions, it gave you the region. Unfortunately, you're going to have to draw it yourself. There's a 50% chance that one of your equations will be linear, like y equals mx plus b. And there's a 50-50 chance you're going to have two quadratic equations like this. So whatever, I can't do anything about that for you. But I can show you how to go about drawing this. So, okay, let's do this one first. So, negative x squared plus 12, okay? Regardless, this is your intercept, right? Like, no matter what, we know this has an intercept of 12. So why don't we draw that? Or mark it, whatever. And then for our other guy, we're x squared plus 6. So we know we're going to have an intercept at 6. Okay? When it comes to drawing a quadratic, two things you need to know. X squared has this shape. Negative x squared has this shape. Okay? Now, let me really quickly do a little bit of investigation. Hang on. Let's see. Yeah. So you could have a negative x squared, or you could have a positive x squared. You could have a linear line. You could have something where it's like 12 plus 6x minus x squared. There could be that third term there. That's fine, guys. It doesn't change a whole lot, okay? As long as you have the general shape and you're not drawing something completely out of nowhere, it's kind of okay. Just have some idea of what a quadratic looks like before you come to this test, okay? So the first line is negative x squared, so I know it's going to have the shape of this. So maybe it looks something like this, right? Again, does it really matter? No, okay? It doesn't really matter that much. Just don't be weird and draw something completely unlike it. And then x squared plus 6, well, because the x squared is positive, it'll look something like this. So maybe it looks something like this. Okay? Now, do I care where this intercepts the x-axis at? No. But you know what I do care about? I do care where these intersect. Okay, but we can figure that out. Okay? But we'll get there in a second. So step 1 is to draw both of these curves to the best of your ability. You can do it, okay? If you're like, Meg, I have no idea how to draw a quadratic. Well, step 1, maybe let's go over to Desmos right now and just practice putting in a couple quadratic equations, getting a feel of what they look like on a graph. So when you get to the test, you kind of know what the shape's going to look like, right? Just maybe some different coefficients. If you're like, that's still not going to help, well, start plugging in some numbers. Start plugging in some x values into here. What are their y values? You know what I'm saying? Like, that might help you, but it's going to be okay. So our goal here is to get this area of this region we have created by these two curves intersecting, okay? So we need to write some integral that will give me the area of this. And it's going to be the top function minus the bottom function. Because think about it. If I just found the area of the top function, which would give me this area, and let's say then I found the area under the second function, then I would have this area, right? You know what area I don't want? The part that overlaps. So that's why I subtract them, and that will just give me this area. Okay, so top minus bottom is what we're gonna do. So if we do that, that'll give us the equation integral 12 minus x squared minus, be careful, the whole thing. Make sure that negative sign gets distributed everywhere, okay? Don't cost yourself some silly little points from that negative sign, okay? Now the question is, from what to what? Well, that's what I was getting on about earlier. We need to figure out where these two intersect because that'll tell us where to integrate from, okay? So these intersect here. That means at some x value, they have the same what? Y value. So why don't we set our equations equal to each other and see what x values they are equal at. Okay, so let's move the x over. So we'll have 2x squared. Let's move the 6 over. So we'll have this. All right, 6 over 2 is 3. Okay, so x is equal to plus or minus square root 3. So that means this x value is negative root 3, and this x value is positive root 3. Okay? Remember that when you take the square root, you get a positive and a negative term. I mean, when you do draw this, you'll have two parts that intersect. And if you solve this and you're only like, oh, well, all I got was square root 3. What's the other one? Negative. Negative and a positive. All right, great. So we're going to integrate from negative root 3 to positive root 3. Don't know why it's in red, but forgive me. All right, let's clean up our integrand a little bit. The good news about these problems is the integration is probably, in my opinion, the easiest part. The setup is what gets you guys a little bit. And that's okay. You can do hard things. All right, so I distributed the negative sign, and now we're going to collect like terms. So these are like terms. These are like terms. We're just making our lives a little bit easier. All right, now we're ready to take the antiderivative. Shouldn't be too much heavy lifting here. Okay, so we're going to get 6x minus 2x cubed over 3. Evaluate from negative root 3 to positive root 3. All right, so that means we need to do 6 root 3 minus 2/3 root 3 cubed divided by 3, same thing as multiply by 1/3. Okay, minus 6 negative root 3 minus 2/3. Oh, no, that's negative. Okay. Do your best to not leave your answer like this unless like you have 0 time. Try to though. All right, I'll try it. Let's see what we get. All right, so this is 3, okay, 3 to the 1/2 to the 3rd becomes 3 to the 3/2. If we want to lose sleep over it. It's not incorrect to leave it like square root cube, but do whatever you want. All right, distribute that negative, we'll get positive. Distribute that negative, we'll also get positive. So that's what? Well, no, because that's negative. This gives us a positive, so that'll be negative. Okay, we can keep going a little bit. These are like terms. So I have 6 plus 6, which gives me 12 root 3. And then I need to do negative 2/3 minus 2/3, which is minus 4/3. Okay, I think that's right. What do you guys think? Like, is this wrong? No, but like, this is a little bit better. Just like, don't be goofy. Okay? Don't be goofy.